Hello boys and girls, so time for the next lecture, and that is elimination reactions, right? So what elimination means? Elimination means removal of something. So tell me, under what conditions things will be eliminated? You have seen Big Boss, you have seen Indian Idol, several other game shows. Why people get eliminated? As per the format of the show, right? For stability of the show and all. So here also in chemistry we are concerned about stability only, right? So what will happen if we are having a statically hindered compound, right? Some of the groups present in that particular compound will be eliminated, right? So elimination reactions are of how many types? Your previous knowledge will tell you that it is of how many types? Tell me. 1, no, 2, 3, right? What are the three names? E1 reactions, E2 reactions, and E1CB reactions, right? Elimination reactions of first order, second order elimination reactions, and elimination reactions via conjugate base, which is not in the syllabus, so we'll focus on E1 and E2. Now, E1 means elimination first order. As you know from your previous knowledge, first order means only one substrate will be present, right? From that, something will be eliminated, resulting in the formation of double or triple bond. Same thing will happen for E2, but there we will be having two substrates in one particular. Basically, two substrate means one substrate and one nucleophile in the predetermining step, right? Addition reactions, right? Our next topic. So what is addition? Uncle and auntie will come. No, I'm not talking about any other uncle and auntie. It is about Markovnikov and anti-Markovnikov, right? A very old uncle and auntie of our choice. Anyway, so Markovnikov and anti-Markovnikov are nothing but rules, and these rules we need to follow whenever we are doing addition reactions, right? So as per Markovnikov addition rule, what happens? I'll not tell you. You people will tell me, right? So I'll wait for a few seconds and need to see. Started? Forgot. Okay. So Markovnikov addition means this addition is applicable for unsymmetrical double bonds, right? So whenever unsymmetrical double bonds are present, the negative part of the adding molecule or the addendum will go to that carbon which has less number of hydrogens, right? Yes. Obviously, the positive part will go to the carbon having more number of hydrogens. Okay. Anti-Markovnikov is the reverse. I'm not telling you. You need to go to the digital content properly. Okay. Just go through the digital content and you will get the details, right? And do answer the quiz after that. We'll meet in the class with the applications of this particular topic. Thank you.
Hey boys and girls, this is G Chakravarti and welcome to the Department of Chemistry. And as you people already know, we people are doing the organic reactions module. And in this particular module, we have already done two lectures, right? Lecture number 21, lecture number 22. And welcome to this lecture, that is lecture number 23. Now, in lecture 21, we people have clearly seen that what electronic effects are and what are the basic divisions of electronic effects, what are the types of electronic effects, right? We have seen inductive effect, resonance effect, hyperconjugation, and several other things, right? We people have already seen that, okay? Now, also we people have seen that how electronic effects actually denotes the stability of carbocations, carbanions, and free radicals, right? Because they have a very, very important role in the chemical reactions. Okay, so this we people have seen in the lecture 21. There is the first lecture of chemical reactions of organic chemistry, and after that we people have seen in the second lecture that what are carbocations, carbanions, and free radicals, how their stability operates, right? And which one is more stable, which one is stable, these people we have seen. And apart from that, we have seen the your substitution reactions, right? Nucleophilic substitution reactions, SN1 and SN2, we people have clearly seen, right? Now, we are left with actually three different topics which are very, very important actually. So these three important topics are elimination reactions, addition reactions, and oxidation and reduction reactions. Basically, there are four, but oxidation and reduction, if they're combined together, then it is three. Okay. Now, in this particular lecture, we are going to see that what the different aspects of elimination reaction and addition reactions are. Okay. So let us start this lecture today, and we will start with the topic which is called elimination reactions. Okay. Now, what these elimination reactions are, how they are related to substitution reactions, this we people will see. Okay. So let's start. And as you people know that elimination reaction basically can be defined as the reactions in which two substituents are removed from a molecule in either one or two step mechanism. Okay, two substituents are removed in one or two step mechanism from a particular molecule. Now if there is one step, then it is called E2 reaction. If it is two step, then it is called E1 reaction. So basically you people can see that elimination reactions are of two types, E1 and E2. If you are thinking that this is correct, your thinking is absolutely wrong. Okay, elimination reactions are also of three types, just like substitution reactions. You people have seen SN1, SN2, then SNI. Here also another type of elimination reaction is there, which is called E1CB. E1CB means elimination reaction first order via conjugate base. Okay, now this particular thing is not in our syllabus, so here we are concerned about E1 and E2 reactions only, right? That's why E1 and E2 reactions are shown here. Okay, so let's move to the next slide and see what is there. Now these are E1 reactions or elimination reactions of first order. Now what is this? Elimination reactions of first order is basically a two-step reaction, right? Similar to that of SN1 reaction, this reaction also occurred in two steps. So you can see this is the step 1 and this is the step 2, right? It is written step 1 and step 2. Okay, now in the first step what happened, and in the second step what is happening, that we people will see, right? Now in the first step, if we see carefully, then what we can predict that this X, this is nothing but the leaving group. So in the first step, the leaving group is leaving the substrate and we are getting the carbocation. Just like SN1 reaction, in the first step, the leaving group is left and we are getting the carbocation. Okay, now you can see this is the carbocation, right? In the second step, what is happening? Here the difference from SN1 reaction is there. The base is taking the proton which is in beta position with respect to the carbon. Just try to understand, this is alpha, this is beta. Okay, so beta carbon containing hydrogen is beta hydrogen, right? So beta hydrogen is taken and the bond between carbon and hydrogen, this particular bond is shifted here to this carbon-carbon position. Okay, and what we people are seeing, we people can see that there between the carbon and carbon we are getting a double bond and two species have left. One is H, another is X, right? So both hydrogen and halogen both are removed, right? That's why this particular reaction is also known as dehydrohalogenation, and it is also called beta elimination because the hydrogen is removed from the position beta with respect to the carbon that bears the cation. Okay, so this is all about the elimination reactions of first order, but we are not done. Some more things are present here, that is the conditions for elimination reaction. So what conditions we people are having? Number one, highly substituted carbon atom or carbocation center such as tertiary carbon atom favors E1 mechanism. Why? Can you tell me what the reason of this particular statement is? The reason is quite simple. See, elimination, when it will occur? Suppose you are sitting in a class of 30 students, a room that has a capacity of accommodating 30 students, right? Now if 60 students are asked to sit there, 60 students are told, okay fine, you go to this class and just occupy your seats. Now 30 students will be extra, so then what will happen? You will want to eliminate those extra students, right, in order to preserve your seat. So whenever there is huge crowding, there little bit elimination actually relaxes the compound, relieves the compound from the stress, right? That's why in order to be stable, this elimination reaction occurs. So highly substituted carbon atoms will always favor not SN1, E1 reactions. Okay. Similarly, polar solvents, if we use, which can stabilize the carbocation, just like SN1 reaction, which can stabilize the carbocation, then that polar solvents will be favorable for this particular reaction, right? Okay, so polar solvents will be favorable and high steric hindrance is required. Okay, so this was all about E1 reactions. Next we are having E2 reaction, that is elimination reactions of second order. Now second order means, you people already know from your knowledge of substitution reaction that first order means only the formation of carbocation will happen and the leaving group will leave. So it depends on the substrate only. But whenever we are saying second order, then two species will be involved in the step. One is the base, another is the substrate. Those two species are involved. That's why it is called second order reaction. Okay. Now, in this particular reaction, what is happening? The mechanism is the same. See, here also alpha and beta are written. What is happening? Hydrogen is taken and this particular bond is here and this leaving group is left. Okay. So H and X are leaving, this green and red, and we are getting our desirable product. Okay. Right. So this is E2 reaction. So let us see what is written here. It involves one step, fine. It is bimolecular reaction that also we people have seen, and abstracts the beta, hydrogen and leaving group. So basically here one thing should be swapped. This particular carbon is beta and this particular carbon is alpha. Okay. The image is little bit incorrect. This is alpha and this is beta. Always remember this. The carbocation bearing or the halide bearing carbon will be alpha and the second one will be beta. Okay. So multiple bond will be formed between alpha and beta carbon atom. That also we people have seen. Okay. The sequences of events, what happens basically, the attack of ethoxide. Ethoxide is the base, this one, right? So base will take the carbon, it will extract a proton, not carbon, hydrogen, right? So base will attack on the beta hydrogen. Okay, it will take the proton, and what will happen? The bond will be shifted. A new bond will be created between the C and C. So the CBr bond, that's X is taken Br here, CBr bond will break. Okay. Now why Br is taken and why ethoxide is taken? Because ethoxide is a good base and Br is a good leaving group, right? That's why they are taken. Okay. So let us go to the next slide and see what is present there. Addition reaction. So before starting addition reaction, let us conclude the elimination reactions. That elimination reactions are those reactions which operates on bulky substrate or light substrate. If bulky substrate is there, then what will happen? E1 reactions will come into being. If we are using some light substrate, then E2 reactions will come into being, right? So it depends on us. It depends not on us, it depends on the substrate, rather what type of reaction will happen. Okay. Now base is required after the formation of carbocation in E1 reaction, so it is first order, and base is required during the formation. No carbocation is formed basically during the formation of the double bond in E2 reaction. So two substrates are used, one is the substrate, other is the nucleophile. So basically that particular reaction is called E2 reaction, that is elimination reactions of second order. Okay. So this was all about our elimination reaction. Now let us move to the next topic, which is nothing but our very own addition reactions, right? Now what is addition? What is the meaning of this word addition reactions, right? Addition means adding something. Now when something can be added, tell me, this is not addition of mathematics, that you will add and add and add and add. When something can be added, under what conditions can anything can be added? The condition is that whenever there is a vacancy, then only something can be added. For example, here it is clearly mentioned that if we are having alkenes or alkynes, that is double or triple bond, then only anything can be added. Because see, single bonds, if it is present, then it is saturated, right? So this type of reaction will only happen with unsaturated hydrocarbon. Okay. So we have to see that whether it is alkene or alkyne, then only this particular reaction will happen, right? Okay, so let's proceed. Now addition reaction occurs in accordance to certain rule. One is Markovnikov rule, another is anti-Markovnikov rule. Right, here there is no third condition. You might be seeing that there must be a third condition, but here there is no third condition. Okay, there are two rules only. One is Markovnikov and the other is anti-Markovnikov, right? So let us see what Markovnikov rule is and what anti-Markovnikov rule is. Okay, so this is what Markovnikov rule says. The rule states that addition of a protic acid like HX to an asymmetric alkene, the acid hydrogen H becomes attached to the carbon with fewer alkyl substituents and the halide is attached to the carbon with more alkyl substituents. The matter of fact is that whenever addition occurs, addition of HBr or this sort of thing occurs, hydrogen halide occurs to an unsymmetrical double bond. Why unsymmetrical? That we will discuss. Then the negative part of the double bond will go to that particular carbon which has less number of hydrogen, and positive part, there is hydrogen, will go to that carbon which have more number of hydrogens. Okay, so as simple as that. Alternatively, also whatever I am saying is alternatively stated, that the hydrogen atom is added to the carbon with greatest number of hydrogen, while the negative part is added to the carbon having least number of hydrogens. Okay, as simple as that. Now we can verify this with the help of the chemical reaction coming right away. See, this chemical reaction will tell us that what Markovnikov addition rule is. Okay, chalo. So see this reaction here. We are not concerned about this. This we will not see. Why we will not see this? Because it has nothing to do with the addition. Okay, we are concerned about this carbon and this carbon. Now here we are having number of hydrogen is 1, and here we are having number of hydrogen is 2. Okay, now we are taking HCl. Now in HCl we clearly know that Cl part is minus and H is plus, right? So negative part will go to the carbon having less hydrogen. So less hydrogen means this. So negative part will come here and the positive part will come here, right? So positive part H will come to CH2 and Cl will come to CH. So gradually we can see H has come here and Cl has come here. And the other chance is the other way around, that is H will, let us take some other ink, that is H will come here and Cl will come here. Okay, so blue one product is this one and red one product is this one, but here it is clearly mentioned that the red product is the major product. Okay, that is 75% product, and next one is the minor product. Why that one is major and the next one is minor, that we people can clearly understand by the fact. Let us just clear this out and try to understand. Whenever H plus is added, suppose we are writing this reaction like this, H plus from HCl. HCl is acid, so it will be dissociated, so H plus will come up. Now if we write these two structures, first one is this one where the carbocation is here and CH3, okay, plus the other structure CH3, CH2, CH2 plus, right? So these two structures, if we consider, just try to understand very carefully, listen. Okay, what we have done, HCl is an acid, it will dissociate to form H plus and Cl minus. Now this H plus will attack on this particular compound, okay, and it will result in two products, product number 1, product number 2, both are carbocation, right? Now if we see this particular structure here, how many substitutions are there? One substitution, there is one methyl group and the other methyl group, okay, so it is 2 degree, right? Now here only one substitution is there, that is ethyl, it is 1 degree, right? And we know it very well that 2 degree is more stable than 1 degree. 2 degree carbocation is more stable than 1 degree carbocation. So 2 degree carbocation, which is resulting in this product, will be the major product, and 1 degree carbocation, which is results in the second product, will be the minor product. Okay, right? As simple as that. Okay, now let us see the next reaction. Here also, as we people can see, HBr is there. So one product is written, that is this one, right? These are the two carbons. This is one, this is the other. This one is having one hydrogen, this one is having two hydrogens. So Br will be added in the middle, and this is the major product. One minor product will also come, but here it is not shown. Okay, so this is all about the Markovnikov addition rule, right? Next we are having Markovnikov type additions, right? Now Markovnikov type addition means it looks like Markovnikov, but it follows Markovnikov addition rule. For example, whenever we are adding H2SO4, this is HOSO2OH, means nothing but H2SO4, right? Sulfuric acid. So what will happen? H2SO4 on breaking, what it will give? This is H2SO4, on breaking it will form H plus and SO4 2 minus, right? H plus and SO4 2 minus. Okay, now this H plus will come up here, so it will be CH3 as it is, and SO4 2 minus will come up here, so it will be this one, right? Markovnikov type addition. Similarly, if water is added, H2O means H plus plus, OH minus. Okay. Now H plus, it will come up here. H plus will come up in the middle, and OH minus will come up in the middle, and H plus will come here. So we can see this is CH3 and this is OH, right? As simple as that. Okay. So these are all Markovnikov type of reactions. Next we are having anti-Markovnikov type addition, but before that we are having reason for Markovnikov addition. This reason we have already discussed, that due to inductive effect and due to hyperconjugation, right? The carbocation stabilization fact is very important. Whatever I have said already, that thing has been discussed here. Okay, that more substituted and less substituted position is there, so that's why Markovnikov addition takes place. Okay. So next what we are having the next slide, that is finally the anti-Markovnikov addition rule. Why I am saying finally? Because 3 times I have searched for it, right? So mechanisms that do not involve carbocation intermediate and which occurs by free radical addition is called anti-Markovnikov rule. It is opposite to that of the Markovnikov addition. Okay. Now, so what is anti-Markovnikov rule? Anti-Markovnikov rule says, suppose we are having CH3, CH, double bond, CH2. Okay. My handwriting is getting worse, but I think you people can understand. Now, if we are having HBr and H2O2 peroxide, HBr and peroxide we are getting, then what will happen? We will get this as the major product. CH3, CH2, CH2, Br. Means whatever was the minor product in the previous lecture, that is becoming major product here. Okay, right? So basically anti-Markovnikov rule states that in presence of organic peroxides, the negative part of the addendum will be attached to the carbon having maximum number of hydrogens. Now here you can see between H and Br, H is plus, Br is minus. So Br is coming here where, oh, this will be 2, sorry, this will be 2. So Br is coming here, which one is the carbon having more number of hydrogen, there is 2 hydrogen, and hydrogen is coming here, which is having 1 hydrogen. Okay, this is what anti-Markovnikov rule states. Now I guess in the next slide the reaction is given. Let us have a look at the reaction. Yes, I'm correct, the reaction is given here. Okay, so in presence of benzoyl peroxide, there is organic peroxide. How it happens? HBr is here, benzoyl peroxide is here, and whatever I have written in the reaction is written right here. Okay, here also the same thing happens. See, this carbon is having H and this carbon is having CH2. So hydrogen has come up here. Hydrogen has come up here. See, this red hydrogen is added and Br will come up here, right? Okay, so this was all about our Markovnikov rule and anti-Markovnikov rule and addition reactions and elimination reactions, right? So in the previous lecture we have seen that what substitution reactions are, and in this particular lecture we have seen what elimination reactions are. Okay, so that's all about the lecture of today, and the next day we will see that what a different type of this reactions called oxidation and reduction reactions. Okay, what is oxidation, what is reduction, this people will see in the next lecture. So stay tuned for the next lecture and study elimination, substitution and addition reactions very well, because these are very, very important for your exam, right? So till then, thank you so much. Stay safe and study organic chemistry and be happy. Thank you.